It is now time to move on to section 3.4, partial fraction decomposition. This is actually a really neat trick that is helpful throughout all of math, not just here. And so I'm going to start by trying to show what partial fraction decomposition is, and then after that, how it's helpful in Cal 2. So first things first, let's explain what partial fraction decomposition is and how I would do it. So remember in an algebra class you would have had maybe in high school or maybe your freshman year at a college, you would have learned how to handle things like, let's just do 1 over, I'm making this up, so that's why I paused. 1 over x plus 1 plus 3 over x minus 4. Let's say we did that. So remember what I would do is I would need a common denominator, right? Well, on this first one, I have a factor of x plus 1. So to match this one, I would also need a factor of x minus 4. So if I do it on the bottom, got to do it on top too. Same thing, in order for these to match, I would need a factor of x plus 1. So let's throw in a factor of x plus 1. And I've got to do it on top too. Now the denominators do match, okay? Because now I end up with 1 times x is x, 1 times a minus 4 is minus 4 over. If we did x plus 1 times x minus 4, x times x is x squared. X times a negative 4 is negative 4x. 1 times x is a 1x. Negative 4x plus x is negative 3x. And then 1 times a negative 4 is negative 4. Plus, do the same thing over here. 3 times x is 3x. 3 times 1 is 3. Over the same thing. So the reason this is helpful is because now they are the same things, which means I can just add across here. X plus 3x is 4x. Negative 4 plus 3 is negative 1 over x squared minus 3x minus 4. So here we go. So this is how I would go from 2 fractions to 1. What partial fraction decomposition is it's going to give you something like this, and we are going to break it up into 2. That's what I want to learn here, is how do I go from this back to having 2 terms? And that's what I want to do. Here's how I'm going to do it. So first things first, if I'm wanting to decompose 4x minus 1 over x squared minus 3x minus 4, first thing I want to do is if I want to break this up into 2 pieces, I know I need to factor this to see what the original factors were that I had. So again, I want to find the factors of negative 4 whose sum is equal to negative 3. Well, that would be negative 4 and positive 1. So I'm going to factor this, and I get x minus 4 times x plus 1. So what this means is that what I would have had was something over x minus 4 plus something over x plus 1. And our goal is to find out what those 2 things are. Okay. Well, think about this. What is the numerator going to look like, right? Well, if my denominator has x to the first, I want to decrease my power by 1. So if this was x to the first, on the numerator, I must just have a constant. So it's going to be some constant. I'll just call it a. And then the same thing over here. I had x to the first here, which means up top I would have just had a constant. So I'll just call it b. So our goal is to find out what a and b are, right? So let's treat this as if I knew what they were, okay? Well, just like I did up here, I would have had to multiply this a by x plus 1, right? Because I would need a factor of x plus 1, which would mean I need an x plus 1 up here. Same thing over here, I would have done b times x minus 4, because I would need an x minus 4 over here. so that they matched. So I would do a times x plus 1. A times x is ax. A times 1 is a. And then plus b times x is bx. B times the minus 4 is minus 4b. And that's going to be over x minus 4, x plus 1. So what this means is ax plus a plus bx minus 4b has to be equal to 4x minus 1. So since I have ax plus bx, I know ax plus bx must be equal to 4x, right? Ax plus bx must be equal to 4x, which means a plus b has to be equal to 4. A plus b has to be equal to 4. Same thing over here. I have a constant a minus 4b has to be equal to negative 1. So I can write that. A minus 4b has to be equal to negative 1. So I'm going to use these to figure out what a and b are. If a plus b is equal to 4, I can bring the b over here and know that a must be equal to 4 minus b. So I know that. Plug this into that a. 4 minus b minus 4b has to be equal to negative 1. Negative b minus 4b is negative 5b. I'm solving it for b, so subtract 4, which would give me negative 5b equals negative 1 minus 4 is negative 5. Divide by the negative 5, and you get b is equal to 1. Well, since I know b is equal to 1, I'm going to plug that back in over here. A would be equal to 4 minus 1. 4 minus 1 is 3, so a is equal to 3. So this means the partial fraction decomposition would be a is 3, so 3 over x minus 4 plus b, which we said was 1, over x plus 1. Which, I mean, we already knew that because we saw it up here, but I'm just showing you how I got that. So let's do some examples of that as practice. And of course, if it doesn't make sense, please reach out and let me know, and I'll help you out. So example number 1 on our handout just says decompose the fraction 3x over x squared minus x minus 2 into the sum or difference of just two fractions. So this one that we want to decompose is 3x over x squared minus x minus 2. I want to decompose that into two parts. So first things first is I need to know what the factors are. I need the factors of negative 2, whose sum is equal to negative 1. Give that a think really quick. Pause it if we have to. That would be negative 2 and positive 1. So our fractions must have been over x minus 2 and over x plus 1. And again, since I had x to the first right here, on top I must have just had a constant. Same thing over here, on top I must have just had a constant. So if I were to add these up, if I knew what a and b were, the factor I would need over here is x plus 1. So I would do a times x plus 1. A times x is ax. A times 1 is a. The factor I would need over here would be x minus 2. So I need to now have b times x minus 2. B times x is bx. B times a negative 2 is negative 2b over x minus 2, x plus 1. Now when working this out, ax plus bx must be 3x, which means a plus b has to be equal to 3. And then a minus 2b are the constants over here. Well, I don't have a constant over here, which means a minus 2b must be equal to 0. Again, because there's no constant over here. So now I can use this. I can solve for a or b in either one of these. Since I have equal to 0 over here, I'm going to solve for a over here. Add the 2b, you get a equals 2b, which I can then plug in over here. A we just said was 2b, so 2b plus b is equal to 3. 2b plus b is 3b. 3b equals 3. Divide by 3, and you get b is equal to 1. Well, so now I can plug that over here. A is equal to 2b, so 2 times 1, and 2 times 1 is 2. Therefore, the partial fraction decomposition would be a is 2, so 2 over x minus 2 plus b is 1, 1 over x plus 1. There we go. Once again, if any part of that doesn't make sense, please let me know. Example number 2 is doing another one of those. Find the partial fraction decomposition of x minus 17 over x squared plus x minus 6. Again, I want to find the partial fraction decomposition of this. So again, figure out what the factors are. I need the factors of negative 6, whose sum is equal to positive 1. Pause it really quick and think about it. That would be x plus 3, x minus 2. So I know my factors are x plus 3 and x minus 2. X to the first down here, which means I'm just going to have a constant up here. Same thing right there. If I knew what a and b were and I were to add these up, I would need a factor of x minus 2 here. So I need to now do a times x minus 2. A times x is ax. A times the negative 2 is negative 2a. And then do the same thing over here. I would need an x plus 3 over here. B times x is bx. B times 3 is 3b. Over x plus 3, x minus 2. So I would know ax plus bx would have to be equal to 1x, meaning a plus b is equal to 1. And then negative 2a plus 3b would have to be equal to negative 17, because that's the constant. So I can solve for a or b on either one of those. Let's just solve for a here. It doesn't matter though, whatever you want to do. A would be equal to 1 minus b if I bring the b over there. So plug that in here. Negative 2 times a, we just said a was 1 minus b, plus 3b equals negative 17. Negative 2 times 1 is negative 2. Negative 2 times the negative b is positive 2b, plus 3b equals negative 17. 2b plus 3b is 5b. Add 2 so that I can solve it for the b. Add 2 and we get negative 15 over here. Divide by 5 and you get b equals negative 3. Plug that in up here. A equals 1 minus negative 3. That's like saying 1 plus 3. So a is equal to 4. So the partial fraction decomposition would be 4 over x plus 3 minus, because of the negative 3, minus 3 over x minus 2. So that's how I use partial fraction decomposition. So now our question is, why does this help us in Cal 2? Imagine if you were asked to find the antiderivative of x minus 17 over x squared plus x minus 6 dx. Our first thought would be, okay, let's try u substitution. U would have to be the denominator. So du would have to be 2x plus 1. I don't have that. So u substitution would not work here. So I would need to find a way to rewrite this to where it's not hard to, to, to work with. So what I just found is I know how to split this into two terms. I know this would be equal to integral of 4 over x plus 3 minus 3 over x minus 2. Why is this helpful? This is the natural log, right? We have learned this a few classes ago. I don't remember what section it was off the top of my head, maybe 2.7. We have learned this is the natural log. So this would be equal to 4 times the natural log of the absolute value of x plus 3 minus 3 times the natural log of the absolute value of x minus 2 plus c. Again, because our rule was that the derivative of the natural log of x is 1 over x, so anytime I have 1 divided by some stuff, it is the natural log. So let's use this to do some examples. Example number 3 is the integral of 3x plus 2 over x cubed minus x squared minus 2x dx. Okay, so clearly here I would see, based on what I know so far, there's no way to solve this, right? So I want to try to rewrite this into a way that's not very hard, right? So I want to split this up into several terms. So I want to factor this out. The difference between this one and the ones I have done is all of the ones I have done have been an x squared. This is x to the third. But if you notice, all of them have x, so I can factor out x. So factor out an x leaves you with x squared minus 1x minus 2, and then I can factor this like I have done, right? I need the factors of negative 2, whose sum is equal to negative 1. That's negative 2 and positive 1. So the factored form is x times x minus 2 times x plus 1. So then what does that do? Instead, I'm going to have 3 terms instead of just 2. So I'm going to have a constant over x plus a constant over x minus 2 plus a constant over x plus 1. So what's going to change here is the number of factors I need, okay? So like for the first term, I not only need x minus 2, but I also need x plus 1. So for the a, I would have to do a times x minus 2 times x plus 1, because I need both of these here. For the b, I need an x and I need an x plus 1. So b, I need an x and I need an x plus 1. For c, I need an x and I need x minus 2. So now let's work that out. X minus 2 times x plus 1. The good thing is we already did that over here, so we know that's x squared minus x minus 2. X times x is x squared. X times 1 is x. And then do the same thing over here. X times x is x squared. X times a minus 2 is minus 2x. So now distribute everything through. A times x squared is ax squared. A times a negative x, negative ax. A times a negative 2, negative 2a. B times x squared is bx squared. B times x is bx. C times x squared is cx squared. C times negative 2x is negative 2cx. So now I know this has to be the same thing as 3x plus 2. So look at all my square terms. I have ax squared plus bx squared plus cx squared. This means a plus b plus c must be, if you notice here, I don't have a square term. So a plus b plus c has to be equal to 0. Again, because there's no square term. For the plane x, negative ax plus bx minus 2cx has to be equal to 3x. Once again, negative a plus b minus 2c has to be equal to 3. And then my constants, the only constant I have is negative 2a. So negative 2a must be equal to 2. So this is nice because I have negative 2a is equal to 2. So I can just divide by the negative 2, which gives me a equals negative 1, which I can now plug into both of these. Negative 1 plus b plus c is equal to 0. Add 1 means that b plus c has to be equal to 1. Negative 1 plus b minus 2c equals 3. This makes it positive 1, which means I want to subtract it and give me b minus 2c is equal to 2. Solve for b or c on one of these. I'll just solve for b here, but that doesn't matter. B is equal to 1 minus c. So that means 1 minus c minus 2c is equal to 2. Negative c minus 2c is negative 3c. Subtract 1 gives you negative 3c equals 1. Divide by the negative 3 gives you negative 1/3. Like that, and over here, b is equal to 1 minus negative 1/3. This is like saying 1 plus 1/3, so b is equal to 4/3. So what this means is how this is going to work out. This is going to be the same as the integral of, for a, we got negative 1. For b, we got 4/3. And for c, we got negative 1/3. Which really helps us out because now I just have stuff divided by x to the first, which we know is the natural log. So I'm going to write this down here. Negative 1 over x just gives us the natural log of the absolute value of x, plus 4/3 natural log absolute value of x minus 2. I ran out of room, so I'm going to move down here. Minus 1/3 natural log absolute value x plus 1 plus c. So really the only, I don't even want to say hard part, but like the part with a lot of work is all of this. This isn't calculus stuff. The only calculus 2 part of all of this is going from here to here. Everything else is just solving for a, b, and c, and that's it. But again, if any of it doesn't make sense, please let me know. I lost my eraser. There it is. Another example. Example number 4. Integral cosine of x over sine squared x minus sine x dx. Now, at first glance, y'all probably panicked whenever you saw this because it's trig stuff, right? And so, how do you factor trig things, right? But remember, we have a trick to where I can rewrite this so that it doesn't look so bad, right? Notice here, the derivative of sine is equal to cosine. So, since I have cosine on top, I can just use u sub and let u be equal to sine of x. Because then du would be equal to cosine x dx, which I have. So I can rewrite this into being integral cosine x dx becomes du. So I'm left with 1 over Sine squared would become u squared minus sine, which is a u. So now I've got to factor this, which isn't hard, because both of these terms have a u, so I can factor out a u. Integral 1 over u, which will leave me with u minus 1. So I can split this into two terms. I could split this into something over u plus something over u minus 1. Oh, should not be another a, should be something different like b. So now let's see what this might be. For these to match, I would need a u minus 1 over here. So I would do a times u minus 1. A times u is a u. A times a minus 1 is minus a. In order for this to match over here, I just need a u. So times by u gives me plus bu. And I know this has to be equal to, my number on top was a 1. So AU plus BU, notice there's no U's over here. So A plus B has to be equal to 0, which just leaves me with negative A to be equal to that 1. So divide this by a negative 1. A is equal to negative 1. Plug that in over here. Negative 1 plus B is equal to 0. Add 1 and you get B equals 1. So this is the integral of A was negative 1, B was 1. So this isn't bad. This is just negative natural log absolute value of U plus natural log absolute value U minus 1 plus C. But I cannot stop yet because this was dx. This is in terms of a U, so I have to plug back in what the U was. So this becomes negative natural log absolute value, U was sine of x, plus natural log absolute value, U was sine of x, minus 1, plus C. Once again, if any of it doesn't make sense, please let me know. I will be happy to help out. Move on to example number 5. Integral of 2x minus 3 over x cubed plus x. All right, so just like we have done, we need to factor this out, right? So I see to start with, both of these have a factor of an x. So factor out an x, leaves us with the x squared plus 1. But then as I can see, there's actually no way to factor this anymore, right? Because I would need the factors of 1 whose sum is equal to 0, which doesn't make sense, right? There's no such pair there. So can't factor this, so then that's going to just stay there. So what I end up with is I'm going to have the integral over x. Since this is just x to the 1, I know it's just going to be a constant. However, this factor is no longer just x to the 1. So it's not going to be a constant right here. I could have something times an x plus, I keep doing a twice. This should be b. I already used a, so I'm going to use b, plus a constant. So again, this is just x to the first, meaning the only thing I could possibly have is a constant. This one, I have an x squared, which means I could have x to the first along with a constant. So be careful with that. X. Same thing, do it the same exact way. In order for these to match, I would need to do a times x squared plus 1. A times x squared is ax squared. A times 1 is a. Same thing, I need bx plus c times the x. Bx times x is bx squared. And c times x is cx. So what this means is that ax squared plus bx squared must be equal to, well, if I notice there's no squared term up here, So a plus b has to be equal to 0. The x is right here. Cx must be equal to 2x, which means c has to be equal to 2. And then the only constant I have here is an a, so a must be equal to -3. Now this is really nice because it already tells us a and c. So for this one, I need to plug in a. -3 plus b is equal to 0. Add 3, and you get b is equal to 3. So this becomes -3 over x plus bx, so 3x, plus c, which is a 2. So this first part isn't hard. This is just the natural log, which is what we have seen like a whole lot of times, right? This is x squared plus 1. So this one will not just be the natural log. So what I would want to try is, let's say I wanted u to be equal to x squared plus 1. This would mean du would have to then be 2x dx. Well, I have much more than just that, right? So that doesn't quite work out. So instead, let's try to rewrite this. Since there are two terms on top right here, I can split it up. So this is going to equal integral. Like we said, this first term, I'm okay with it. My first one would be 3x over x squared plus 1. This one would be plus 2 over x squared plus 1 dx. Now these I can do because I'm going to erase this so that I have some room. But we said c is equal to 2, a is equal to -3. Okay. Because for the first one, that's not hard. That's just -3 natural log absolute value of x. That's what we have seen. For this one, I would want to do u equals x squared plus 1, which would mean du would have to be 2x dx, but I have 3x. I just want 2x, which means I need to multiply this. If I wanted 2, I need to times by 1/2, which would give me 1/2 times 3, so 3/2 is what I have on top. 3/2 times 1 over u, which would give me the natural log of the absolute value of u, and u is x squared plus 1. Again, I'll rewrite that down here because I did that a little fast. If I was just doing the integral of 3x over x squared plus 1, I could bring out my 3 out front, right? So I would let u be equal to x squared plus 1. So du would be 2x dx. I need a 2. I don't have a 2, so I need to times it by 2, which would mean I need to divide it by 2, which would then give me 3 over 2 integral. 2x dx is now du. X squared plus 1 is just 1 over u. 1 over u we know is the natural log. Plug back in what the u was. That's where I get this from. Sorry I did that fast. And then this last part over here, 2 is a constant, so I can bring it out front. The antiderivative of 1 over x squared plus 1, we saw this in calculus 1. That is the inverse tangent of x plus c. Once again, if any of that isn't clear or doesn't make sense, please let me know. I will be happy to help you out. For those of y'all following along on the handout, example number 6, we are going to skip it because the numbers do not work out nicely at all, and it becomes way harder of a problem than what we really need. So then we're going to skip number 6 and go to number 7. This one's an interesting one. Let me explain why. Integral x minus 2 over the quantity 2x minus 1 squared times x minus 1 dx. So what's nice about this one is that it's already factored out. That's really nice. So I don't have to really worry about that part of it. But what's complicated about it is that I have one of the factors being squared. So what does this mean? This means when I decompose it, I've got to write it a certain way. Think about this. The factors of this could have come from 2 minus x by, or sorry, 2x minus 1 alone, or it might have come from 2x minus 1 being squared. Because think about it like if I was doing 1 over x plus 1 plus 2 over x plus 1 squared minus 1 over x, right? The answer I'm going to end up with for the factors to all match is just going to be something up top, and x times x plus 1 squared. I don't need x plus 1 cubed because x plus 1 is already there, already here twice, right? So the x plus 1 from over here is already there. I don't need to really worry about that here. I just need an x there. Same thing over here. To match all of these, I just need x plus 1 squared. Well, I already have one of them. I don't need 2 more then. I just need to add 1 more to make it an x squared, right? So what this means is that since I have 2x minus 1 squared, I could have come from just a factor of 1 or a factor of 2 like what I have here. So if a factor is being squared, I write it out with two terms, one of them just once, one of them being squared. If that doesn't make sense, let me know. And then the other factor is just x minus 1. So I have x to the first here, which means I just need a constant. Same thing, my factor just has x to the first, so this will also just be a constant. Even though this is squared, my factor just has a power of a 1, so it's still just a constant. A power of 1 here, so that's just a constant here too. So now let's add these up. To match everything else to this a, I already have 2x minus 1. What I can see here is that I want it squared, but I already have one of them here, so I only need one more. So I would just do 2x minus 1 times x minus 1. Moving on to the b, I already have 2x minus 1 squared, so I don't need that factor over here. I already have it. So the only thing I need for b is x minus 1. And then for c, to match all of these, I need 2x minus 1 squared. So let's do 2x minus 1 squared. So times this all out. 2x minus 1 times x minus 1. 2x times an x is 2x squared. 2x times a minus 1 is minus 2x. Negative 1 times an x is a minus x, which will give me negative 3x. Negative 1 times a negative 1 is positive 1. A times all that. And then this one's just bx minus b. That's easy. And then 2x minus 1 squared, if we squared it out, remember squaring it means I do it twice. 2x minus 1 quantity squared is going to be 4x squared minus 4x plus 1. Multiply by a here, 2ax squared minus 3ax plus a plus bx minus b plus 4cx squared minus 4cx plus c. And so now let's see what equations I can make here. For the squared terms, I have 2ax squared plus 4c x squared, which means 2a plus 4c. Since there are no squared terms in this over here, that has to be equal to 0. Now I have negative 3ax plus bx minus 4cx, means negative 3a plus b minus 4c has to be equal to, this is 1x, so just 1. And then my constants are a minus b plus c has to be equal to my constant, which is negative 2. So let's start somewhere. Right here, let's start here. Let's solve for a. So subtract 4c, 2a equals negative 4c. Divide by 2, a is equal to negative 2c. So I can plug in that. This would make that negative 3 times negative 2c plus b minus 4c equals 1. Negative 3 times a negative 2 is positive 6c. 6c minus 4c is 2c. So b plus 2c equals 1. Same thing over here, plug it in for a. Negative 2c minus b plus c equals negative 2. Negative 2c plus c is negative 1c. Negative 2. I can solve for b or c in either one of these. Let's just solve for b over here. Add c. Negative b equals negative 2 plus c. Divide by a negative 1. b equals 2 minus c. Plug that in for b. 2 minus c plus 2c equals 1. Negative c plus 2c is positive 1c. Subtract 2. c is equal to negative 1. Plug that in here. b equals 2 minus negative 1. That's like saying 2 plus 1. So that's going to be 3. And then plug c into here. Negative 2 times negative 1. So a is going to be equal to 2. So this is going to be equal to the integral of a we said was 2. B we said was 3. C we said was negative 1. So I have it broken down to this. All of those we learned how to do in Cal 1. So, working this out, for this one right here, I would want u to be equal to 2x minus 1. So du would have to be 2 dx. And look at that, I already have 2. So that's going to make this equal to the integral, just for this first part right here, of 1 over u du. Do the same thing over here. This one would be u equals 2x minus 1. So du would be 2 dx. I don't have a 2, but I have a 3. So that's going to make that 3 halves integral 1 over u squared. So that's like u to the negative 2 du. Then for this one, I don't really have to worry about it because if I let u be equal to x minus 1, du is just equal to 1, which I already have. So I could even just leave this one as negative integral 1 over x minus 1 dx, and that's fine. Integral of 1 over u is the natural log of the absolute value of u, but we said u was 2x minus 1. For this one, I have a power of negative 2, so I would add 1, which would make it negative 1, divided by my new thing would make this negative, so minus 3 over 2 times our u is 2x minus 1 to the negative 1, minus, this is just the natural log, absolute value x minus 1 plus c. Once again, if any of that doesn't make sense, please let me know. I will be happy to help out. No problem. I would rather you get help than not get help. So ask me if something doesn't make sense. Example number 8. Integral of x plus 2 over x plus 3 cubed times x minus 4 squared dx. So again, do this one the same exact way. This one I have a factor to the third. So just like how on the last one I had a factor squared, meaning I could have anything lower too. So like for this one, I could have x plus 3 by itself, or I could have x plus 3 squared, or I could have x plus 3 to the third. Then this factor is squared, so I could have it just x minus 4, or I could have it x minus 4 squared. All of these have a power of a 1 inside, so they're all going to be constants. So let's see what I've got to do to make all of them match. So for this first term, I already have an x plus 3, which means I just need 2 more. So I need a x plus 3 squared. And then, of course, I need this other factor that I don't even have yet, x minus 4 squared. Plus, for this one, I already have x plus 3 squared, which means I just need one more of them. So this is going to be b x plus 3. And then, of course, I don't have any x minus 4, so I need all of them. For this one, I already have x plus 3 cubed, so I don't need these in. I already have them. So I just need x minus 4 squared. For D, I don't have any x plus 3s, so I need all three of them. I already have one x minus 4, so I just need one more. And then for E, I already have x minus 4 squared, so all I need is the x plus 3 cubed. So now we need to multiply all of this out, which is so much fun. What I'm going to say, I'm actually on for number 8, I'm going to go ahead and stop there because I worked it out on my own in my notes before this because I wanted to practice them before, I do this. And this is me working it out, okay? I spent a long time on this, a lot of room here, and I realized that the numbers you are going to get are disgusting. And so I made the decision to where I was going to show y'all how to set it up, but I would never have anybody in one of my classes have to solve for A, B, C, D, and E unless it worked out. These numbers do not. The numbers are very bad and very gross. So I made a choice to just show y'all how to set it up. And then in the future, if I give you a problem that is like this, the numbers are going to work out. These numbers don't, so I'm not going to worry about it. I'm not going to waste y'all's time or, quite frankly, my time doing it whenever the numbers are horrendous, okay? But if any part of this does not make sense, let me know. So on that note, we're going to move on to example number 9. Oh, and also just so that I'm clear, I checked this to make sure I did everything right, and I did. This is just how bad the numbers are, so not going to worry about it. So moving on to example number 9. 9 and 10 are fun, and I'm going to show you why. Number 9 is the integral of x squared plus 3x plus 5 over x plus 1. So let's talk a little bit about why this one is peculiar compared to the other ones. Notice my power on top is higher than on the bottom. So if I tried to partial fractions this, it wouldn't work. First of all, because I only have one fraction here, so that doesn't make sense. And then plus, again, my power on top is higher. So what I'm going to use here is a skill you would have learned in college algebra or pre-calculus or whatever class you had before Cal 1, long division. So what I'm going to do is actually divide these out and see what I get. So x squared plus 3x plus 5 divided by x plus 1. And I am going to refresh us on how I do this. So how I do this is I look at the first term out here and I say, okay, what do I need so that x is x squared? Well, I would need x times an x. So I'm going to put an x up here. Again, because that's how I get to x squared. So then I'm going to take that and times it by everything I have right out here. X times x is x squared. X times 1 is an x. And then I'm going to subtract that. X squared minus x squared, they cancel out. 3x minus 1x is 2x. And then bring my next term down and do the same exact thing. So what do I need for x to be 2x? Well, I need a positive 2. Then do 2 times all of that stuff. 2 times x is 2x. 2 times 1 is 2. Subtract it. 2x's cancel out. 5 minus 2 is 3. and there are no more terms over here, so I can stop right there. This means I have a remainder of 3. So this is plus 3 out of that x plus 1. If any part of that doesn't make sense, I'll try to link a resource on a reminder of how I do this. But if any of that doesn't make sense, let me know. I'll help you out. So what this means is this is equal to the integral of x plus 2 plus 3 over x plus 1 dx. And this isn't bad because I could work with each of these terms here. The antiderivative of the x is x squared over 2. For 2 is 2x, and this is just the natural log. So plus 3, natural log, absolute value, x plus 1 plus c. So this is a skill that might be helpful. Again, I will try to link a review about that. Last example we are going to do is example number 10 on the handout for those of y'all in my classes. We're not going to worry about it. What the last ones are is I always try to link it to a skill from chapter 2, but we're not going to worry about it. Example number 10 is going to be the last thing we do. Integral of x squared plus 3x plus 1 over x squared minus 4 dx. So the same thing here. My power on top is the same, which means I've got to long divide this first because my power on top should be smaller. The trick though here, notice I go straight from a squared term to a constant, which means I skipped x. You can't skip things. So I'd write this as x squared plus 0x minus 4. So do this again. How do I get from x squared to x squared? Well, I times it by a 1. 1 times x squared is x squared. 1 times 0 is 0. 1 times a negative 4 is negative 4. Subtract that. X squareds cancel out. 3x minus 0 is 3x. 1 minus negative 4 is like doing 1 plus 4, so plus 5. And there are no terms over here left over, so I stop. This is my remainder. So this becomes the integral of 1 plus 3x plus 5 over x squared minus 4 dx. Now what has changed from the last one to here is that this one I need to now split up into 2 because I have an x squared right here. So now I've got to use partial fractions for this part. So first things first, I factor x squared minus 4. That factors to be x minus 2, x plus 2. So this is going to become the integral of 1 plus, one of them is going to have a denominator of x minus 2, one of them is going to have x plus 2. Both of these have a power of a 1, so it's just going to be a constant. For these two to match, I would need an x plus 2 right here. A times x is ax. A times 2 is 2a. And then over here, I need an x minus 2, so bx minus 2b. Ax plus bx has to be equal to 3x. So a plus b has to be equal to 3. 2a minus 2b has to be equal to 5. I can subtract b to solve for a. Plug that in over here. 2 times 3 minus b minus 2b equals 5. 2 times 3 is 6. Minus 2b minus 2b equals 5. Negative 2b minus 2b is negative 4b. Subtract 6, you get negative 4b equals negative 1, so b is equal to 1/4. Plug that in over here. That's 3 minus 1/4, which is 11/4. So a is 11/4, b is 1/4. So now I can just take the antiderivative. The antiderivative of 1 is x. This is just the the natural log. So this is 11 over 4 times the natural log absolute value of x minus 2 plus 1/4 natural log absolute value x plus 2, and of course plus c. So as I have always said, and as I will always say, if anything doesn't make sense, please let me know. I will be happy to help you out.